Moving to the cloud has never been easier with Nutanix cloud clusters, and we're making it even easier by adding additional storage configuration options so you have the ability to move any workload regardless of the capacity needed. Let's take a look at what we've added with Elastic Block Storage support. Nutanix Cloud Clusters now supports Elastic Block Storage for AWS clusters. EBS storage will provide a secondary tier of storage to go along with the bare metal storage that comes with the bare metal nodes. This will allow greater use cases to be placed on NC2 by providing the additional storage and achieving cost efficiency by right-sizing workloads so you can reduce the number of nodes running in your environment and also save on licensing costs. And at a later time, if your business requirements change, you can always add more EBS storage to your environment. While an NC2 cluster has always supported Elastic Block Storage in the form of the hypervisor and our storage controller, now EBS storage is being used for the workloads running on the cluster. We're using GP3 base volumes that have a performance envelope of 3000 IOPS and 125 megabytes of bandwidth per volume. This will allow your bare metal node to achieve 200 terabytes of total capacity for a single node, though if you're using features like Nutanix DR, you're still going to have to follow best practices and guidelines around those storage requirements. The EBS volumes are going to be placed uniformly across all of the nodes, meaning if you had started your NC2 clusters with 30 terabytes of EBS storage, it would be 30 terabytes of storage on every single node. If the EBS volumes need to be replaced, it will be done so automatically. And if you lose an entire EC2 node, we will replace the node and any attached EBS volumes for you. From performance perspective, you can see greater performance than the hybrid models using hard drive, 6x performance for random reads and writes, and for sequential reads and writes, you're going to see very similar performance as on-prem. Tiering the data from the NC2 bare metal nodes storage to the EBS storage is using the same tiering mechanisms that we've used in the past for our on-prem models. But now if you go look at the Prism Element page under hardware, you will see a cloud SSD tier that represents the EBS volumes. Here we have an example around cost efficiency where a Nutanix customer wants 210 terabytes of capacity. On the first example, they're using 4 nodes of i3EN to get to 210 terabytes. So 4 nodes using 60 terabytes coming from the local capacity achieves their outcome. But now that same customer can get away with only using 3 i3EN nodes as the customer is adding 10 terabytes of EBS storage instead of adding the additional node to achieve the same amount of storage, thus leading to a 14% cheaper option than they would have had before. Here is another cost efficiency example using Elastic DR. We have a DR cluster based in AWS that's using i4 Metal. Along with its local storage and EBS storage, we're roughly getting 15 terabytes of usable storage per node. As more DR workloads land on the cluster, instead of adding additional nodes, we can now just add additional EBS storage by moving the slider across. As we add more storage to the node, all of the nodes will have a uniform EBS storage attached. So we can get up to 250 terabytes in our 3-node cluster. And if we need additional storage, we could add a 4th node, getting to 335 terabytes of storage. When the failover needs to happen, if you're short on RAM and CPU, you can add additional nodes at the time of failover, assuming that you have some workloads that are more important that will fail over right away. Less important workloads can be started after the fourth node gets added in. Typical times for adding nodes in AWS is roughly 10 to 12 minutes per node. We're going to deploy a cluster that has EBS attached. At this time, it needs to be at cluster creation to enable it. Give our cluster a name. We're going to deploy this cluster in our North Virginia region, where we have our networking set up in the US East 1B availability zone. Now we're going to pick our licensing and pick a model. So i3 and the i4 models are supported for EBS storage. You can easily select how much EBS storage per node that you want at the time of cluster creation. You can start small and then always add additional storage after the fact. So we're using an existing network. You can create a new environment and the portal will do that for you. A lot of our customers have existing deployments in AWS where we can slot right in. We're not going to deploy Flow Virtual Networking for this environment, but it is supported with EBS attached. And we're not going to choose to use Cluster Protect. We'll create the cluster. So this will take about 20 minutes for the cluster to be initialized. While the cluster is being created, we can see the nodes starting to come up in the portal in the initializing state. And we can also check the current amount of EBS storage that they will be starting with. So if we go to the storage tab, we can see all of the additional volumes. The ones that are 7,500 have our EBS volumes that we've attached. The other two are for the hypervisor and the CVM. Here we can see the performance envelope that we've discussed earlier in the video. So 3000 IOPS and 125 megabits per second. Now that our cluster is up and running, we can go into Prism Element. We have a VPN already established, so going to use my jump host to log in here, which we've already done. Now if we take a look at the hardware tab, we'll see the volume show up here under for each node. The ones listed with AWS are the direct attached, and then we have our volumes for EBS being listed. And then we can also take a look at the tier that they've been placed in. So if you see the cloud SSD tier, that is your EBS tier. So following the same access requirements and capacity limits, well, your data will be automatically tiered down to the EBS storage. Now that the cluster is running and we've taken a look, we can always increase capacity as well. So here are current EBS volumes that you can also see from the portal if you need to find which ones are located on the clusters. Going to add 30 terabytes to each node. This will roughly take around 20 minutes for the volumes to be attached and configured and formatted properly for the cluster. Now we can see some of them are already attaching in the environment. And if we go back into our cluster, we can see the additional storage capacity being added as well. So pretty easy to change it on the fly. There's no need for rebooting the software. It'll be business as usual. And in here, we can click on our storage and see the additional volumes being attached as well. It should be mentioned as well, while you can change the performance metrics of the volumes, it's not supported by Nutanix because as you move and add additional volumes, the settings will not be retained. Move all of your high capacity workloads over to Nutanix Cloud Clusters while saving money on your bare metal costs with EBS support, and have the flexibility to change it when your business demands. Thanks for watching, and we'll see you in the next video.